got the wrong documentary.
Rule that has existed with humankind for many generations. That rule is extinction is the rule and survival is the exception. Now that is what we choose. So we all know that the earth is dying and the sun is dying as well, and that's a problem because we humans need earth to survive. NASA has picked a new planet for us to move to, and that planet is Kepler 62F. Kepler 62F is 1,200 light years away, and that's a problem. But we have decided to use warp drive to get there faster. On our way to Kepler 62F, we will set signal relayers along the way so that we can get a signal back to Earth. Now, once we get there to the planet, we'll send out 2 probes. And how the planet looks like will determine what the probes look like. If the planet is rocky, then wheels will fold out from underneath the probe, causing it to roll on land. But if the world is water, 3 propellers will come out of the back and allow it to propel through water like a submarine. Now, our first probe is named Game Mal. But our second probe is named Zwinky, after the great scientist who came up with the Big Bang Theory. And Gamow was a great scientist who came out with the theory of supernovas, which was proven true. Now, if Gamow can't finish its mission, then Zwinky will be sent down there as a backup probe. Also, Kepler 62F's planetary system is KOI 701.04. Kepler 62F is located near constellation Lyra. Kepler 62F goes through a year every 267 days. Kepler 62F is 2.5 times the mass of Earth. Kepler 62F is 1.41 times the radius of Earth. Kepler 62F can get up to temperatures about 21 Celsius when Earth reaches temperatures about 15 Celsius. That is all you need to know. In order to travel to Kepler 62F, we need to know a couple facts. Those facts are, Kepler 62F is roughly about 1,200 light years away from Earth. It was discovered by scientists in April 2013 and has been confirmed to be an Earth-like planet. The planet orbits in the habitable zone of its host star, an area which would allow for the presence of liquid water on its surface. Kepler 62F is approximately 40% larger than Earth. With such a small radius, it is highly possible Kepler 62F is a rocky world. Kepler 62F will probably have a gravity 2.2 times greater than Earth. Kepler 62F is believed to be 2.5 to 3 times greater than our planet. The planets orbit the star Kepler 62, an orange dwarf with a mass around 70% that of the Sun and emitting around 1/5 of the energy. Kepler 62F's exoplanetary system is called the Kepler 62 system. The Kepler 62 is... I messed that up.
Not only will transmitting data be a problem, but so will the cost. The cost is estimated around $40 trillion. Now that's a lot of money. And not only that, we will have to work together as a whole world, otherwise we can never achieve this. If we are to work off of a single nation, that nation may become bankrupt. And not only will money be a problem, so will power. What nation would enjoy another nation driving a gigantic starship out of the Earth's orbit in order to explores space. Such powers, such as North Korea or China, would try to overtake this spaceship in order to use it for other advantage. Imagine the starship being a gigantic weapon. Unless Earth altogether works as a team in order to help keep humankind alive, this mission may never work. However, if this project does work, a starship named I.G.S.S Archimedes will be sent out into space in order to study Kepler 62f. The way this satellite will work has many components to it, including a spatial storage, magnetic warp drive, different type of cameras, JavaScript coding, and such other components that are too many to name. One of the most important components of I.G.S Archimedes is the transmitting probes. Being that this ship would be useless, just being sent out into space and not being able to transmit a signal back to Earth, we would need to make signal relayers in order to transmit these signals back to Earth. Even though this may take an approximate year, this will be very efficient. This works by using a same idea as reflecting a light off a mirror into another mirror, and that loop continuing. With that, this will work by Archimedes sending a signal to one probe, and this probe sending to another probe every 3 astronomical units until it hits Earth. Another important item is the spatial storage. Spatial storage works by decomposing an item into its atom state, such as decomposing a rock into pure atoms. This is especially useful while we are storing the probes. Being that we will need a rough estimate of 26 million probes, it will be hard to just stuff it in a cargo bay. Also, this will be helpful for making sure that all of our research components does not get contaminated, such as when Swinky or Game Owl brings back water or rock or minerals. We need to put these items in a careful environment in order to prevent any other bacteria from growing on it and modifying it. This function works by having spatial pylons which decompose or compose the items. Once the item is decomposed into its atom state, it is stored in a spatial storage cube, of which then stores the atoms. With that, we can either magnetize it or demagnetize it in the computer, of which then can code in binary of how the items should be modified. This also is very useful while we are traveling across space, because who knows, if we happen to come across a broken piece, we can put emergency broken parts in here, and then if, let's say, I.G.S Archimedes breaks down, we can easily repair that item.
Hello, my name is Jordan Burton, and I am a future NASA mechanical engineer. Me and my colleague, Branson Dow, have been working on a new air-powered satellite engine. So here's how this engine works. So here are 2 backup air canisters. First, these 2 backup air canisters will shoot out here the main exhaust vent, causing the satellite to move away from the space shuttle cargo bay. Then what will happen is, once the satellite is in position, the shuttle drivers and the satellite will send an OK message to mission control saying that everything is working perfectly and everything is going smoothly. Then,
The air engine will also complement the magnetic field, which is based off of the Alcubierre warp drive. This magnetic field works by electrifying the air inside the magnetic field. It works by expanding in the front and collapsing in the back, propelling the ship. Being that this process will release a lot of energy and take a lot of energy, we must calculate how much energy we release to see how much temperature and how high the temperature would go. It works. The equation to find the total energy would be total energy equals warp drive equals energy plus the field to the 3rd power plus the mass of the spacecraft plus the mass of the spacecraft plus field minus the collapse plus the air engine energy and acceleration. With this, we will be able to calculate how much energy is being released, and with that, we will be able to calculate how fast it will go. And with this, it will take approximately 1 day for the starship in order to reach Kepler 62F, which is 1,200 light years away from Earth. There will also be many other features on the starship Archimedes, such as the signal probe, of which is powered by a normal air engine, solar panels, has a high-gain antenna, and a computer storage in order to duplicate, save, and send the signal. Another thing is the RFOVC cameras, the retinal field of view camera. This works by zooming out of a picture, then zooming in, taking a full view of that picture surrounding. With that, we will be able to get more information in one click of a button. On the ship, being that this would be roughly 1,200 light years away from Earth and would take roughly 1 year for a signal to come there and come back, we will be using JavaScript coding using the event if or else in order to detect and or use in order to code. With that, there's many things that will be coded with this. One of the such thing is the capsule grabber. This capsule grabber will be going down in order to capture the probes Gamau and Zwicky on Kepler 62F surface. This item will use a claw, grab, encase the rover, and then blast off with normal liquid fuel launch procedures. Another thing will be the solar panels, of which will have light detection sensors. Each cell is 8 by 8 feet. With that, this ship cannot work all by itself. It will need to use many if or else coding, roughly about 100,000 lines of code in order to predict all possible events, such as if the surface of Kepler 62F is hot, cold, water, or rocky. This can detect anything, and we as a nation to work together in order to make this dream possible. And with that, while we're on Kepler 62F, it will be worthless without some kind of probe that can measure it. So, with my colleague Jordan, he will explain how the rover will work on when it is deployed onto the surface of Kepler 62F.
How the planet looks like will determine what the probe looks like. If the satellite Archimedes confirms that the planet is a rocky world, then Gamewell will land with its wheels transforming and coming out a sliding door located in the bottom. If the satellite Archimedes confirms that the planet is a water world, then 3 propellers will come out the back, allowing it to become a submarine. 3 vacuums will be located at the top and the bottom to collect samples of dust, water, and air. Then it will be sealed in an airtight seal containment area and will be brought back to Earth for study. Also, 2 arms and containment areas will be located on both sides of the probe. The bionicle arms will pick up rocks and collect samples of things and bring those back to Earth for study. The probe will be infused with JavaScript or if or else coding. What that is basically the probe will scope out the area, and let's say if there's a rock in the way, then the probe will calculate all possible situations and pick the best one. Then if the problem comes that the probe is not programmed to solve, then the satellite Archimedes will try to solve the problem. Once GameWow is done with its mission, it will send a message to Archimedes, and a satellite will send a shuttle to pick up the probe. Now, in case that GameWow cannot finish the mission, then another probe, GameWow's twin, Zwinky, can finish the mission. Now, we named it the probe Zwinky because Zwinky was a famous scientist that designed the Big Bang Theory.
Even though we have all this technology, scientists here on Earth have predicted that this world could be a water world, with many possible looks. However, it might be useless to humans unless it meets these criteria. The planets will need the elements of carbon, oxygen, iron, calcium, chlorine, fluorine, magnesium, and contain silica to support life. The planets must be in the habitable zone or the Goldilocks zone in order for water to form. The planet must rotate a star and get heat from the star. The planet must have an ozone layer, and a world with water must have a moon that orbits it if the sun's gravitational pull is not strong enough, and the planet must have a core. not only that, it must have some lithosphere in order for humans to at least have a basic structure to build on, such as making a small little base or a small little hut in order for basic scientific measures. Now, if we're lucky and all of these criteria are met on the planet, we may be able to find some life. Some possible life forms are these fish, which could possibly have the biggest mouths in order to engulf water, and with that find all the food needs. Being that Kepler 62f is a predicted water world, we may find a lot of animals which use the water to its advantage, such as gigantic land suckers that use the water and freeze it in order to make a platform to live on. Now, if humans do come here, we will have to find a new ship. We could reuse the I.G.S.S Archimedes as a new Star Trek ship. If we ever happen to inhabit Kepler 62f in event of dire emergency, we could make self-sustaining habitats, such as bring the tundra biome or the deciduous forest. If we are to bring all these biomes and homes towards this Kepler 62f, we could happen to make a new planet. And if we make this new planet, we could also use it as a pit stop. If we use a pit stop, we can also travel to our neighboring planet, Kepler 62e, and with that, have two planets right next to each other in order for other habitable zones. If this mission is a possible success, we could basically have a huge apartment, of which we can always move back and forth from. Now, if we happen to inhabit Kepler 62f, we would have to majorly use the possible water. We could possibly use the water as a hydroelectric source, or even making ice and making igloos. We could also make gigantic ice structures instead of just mining for cement and such. If we do inhabit this, we could, instead of using our normal tradition bricks, which could erode, we could instead use ice, which is a renewable resource, being that it will melt. Also, while we are on the Kepler 62f surface, we will also have windmills and solar panels, being that Kepler 62f is really close to Kepler 62, its star. Now, even if we do happen to inhabit it, it will be a huge change, as the gravity on Kepler 62f is really greater than on Earth. Also, if we do inhabit Kepler 62f, it will require a bunch of starships. Starships such as the U.S.S Enterprise or the I.G.S.S Archimedes could be easily remodeled in order to fit commercial transportation. Even though warp drive may cause a bunch of problems, we could use it to our advantage. Instead of just using satellites in order to move to this new planet, we could move in bulk, and if daring enough, we could even try to store those humans in the spatial storage. Now, we don't know if there will be aliens on the planet, but if there will, probes Gamow and Swicky will be able to report it. If we do happen, so this project may take a couple of years, being that the transmissions would take a long time. The estimated transmission time is 1 year. The plan to transmit is sending the signals in bulk, and if we happen to find a new way in order to electrify the signal in order for it to travel faster than light, we could possibly make the signals transfer to Earth within a matter of seconds. However, we must remind that if we are on Kepler 62f, it will take a long time to adjust to the new system, as there may not be land, and we may have to make an artificial land in order to build on. If we happen to inhabit 62f, we could also always move to Kepler 62e, of which then we could have two worlds in case one happens to blow up. However, we do not know if we can ever go to Kepler 62f with our technological state. We may not ever be advanced enough in order to use spatial storage or warp drive. This does propose a good idea for future explorers of which need to escape Earth. Who knows if we may deplete our resources in the next 50 years, the sun daring to blow up in our face, ready to make the whole human era nothing. However, there will always be a comet that will stick without this mission. Extinction is the rule, survival is the exception.